Good evening. It's January 9, 2023. This is Professor David J. De Los Reyes. Our topic for tonight will be advanced mathematics. This will now be the introduction, lecture for advanced mathematics. So actually, this is now ADB-M number 1, meaning Advanced Mathematics number 1, meaning lecture number 1 under the topic Advanced Mathematics. So the title of our subject matter for tonight will be Advanced Mathematics. This is higher than differential equation. And the first topic will be higher order non-homogeneous differential equation. It is still a differential equation, but the order is higher order, and the difference from the ordinary differential equation is that the right hand side is not equal to 0. So we are solving an equation, a differential equation, which is of higher order, and the right hand side is not equal to 0. The right hand side is designated by small letter f as a function of x, where small letter x, okay, it is placed here, a function of a small letter f as a function of x, meaning what will come out on the right hand side, since it is not 0, under non-homogeneous differential equation, it could be combinations of algebraic expressions, sine function, cosine function, or exponential function. Anything of algebraic, sine function, cosine function, or exponential, that may come out on the right hand side. So if the right hand side is just a pure algebraic expression, it will just be a pure algebraic expression. But if there is a sine function, it could be. If there is a cosine function, it could be. If there is an exponential function, it could be. And maybe that's the worst problem that we will be solving. But I am telling you, the right hand side might be a combination of algebraic expressions, sine function, cosine function, and exponential function. Am I going past for tonight? No, because this is just a continuation of differential equation. The only problem is that the right hand side is not equal to 0. So supposed to be the solution is, we will use advanced solution. Okay, I will try to check my camera. That is advanced mathematics. It is still a differential equation problems, but the order is higher order, and topic number 1 is non-homogeneous differential equation. Non-homogeneous meaning the right hand side is not equal to 0. An example of this, okay, I will be placing this one on the bottom side. 2d cubed y over dx cubed minus d square y over dx square minus 3 dy dx plus 4y. Originally, under the second order differential equation, the right hand side is 0. But since we are on the topic advanced mathematics, the right hand side is not 0. And for this first example here, the right hand side is an algebraic expression. Okay? The second one, it is still a higher order derivative on the left hand side. And if you try to notice it, the right hand side is an x squared plus sine of 2x. It is a combination of an algebraic function or expression plus a sine function. That's one possibility. It could be a cosine function, maybe the second one. Or the second one may be an exponential function. That's a possibility. So, as an example of a higher order non-homogeneous differential equation is that we are given a higher order derivative on the left hand side, and the right hand side is a combination of algebraic function or a sine function, a cosine function, or an exponential function. So if you are seeing a higher order differential equation in which the right hand side is not equal to 0, supposed to be that is a higher order non-homogeneous differential equation. Okay, so we now know the difference of a higher order non-homogeneous differential equation. We are given a higher order derivative on the left hand side, and the right hand side should not be equal to 0. Okay, the form under the higher order non-homogeneous differential equation is this one. This is the form. That is the general form. I will try to read this one. A here are coefficients. The meaning of this, e sub n, this is the derivative raised to n over dxn. If this is n, this should be n, this should be n, right? The second coefficient will be a, another coefficient, n minus 1. So if this is n minus 1, this should be n minus 1, this is n minus 1, right? Plus dot dot dot. The second to the last will be an a1 dy dx. Why only dy dx? Because this is 1, this should be to the 1 and to the 1. Okay? But if the power is 1, actually we don't place it anymore. But supposed to be, you are imagining under a sub 1, this is actually d to the first, and this is dx to the first. And this last part is actually a sub 0. Okay? This will not just be multiplied by y. Because the second to the last is the first derivative. So the last part will be a pure y plus a coefficient. And for it to be non-homogeneous, the right-hand side should be function of x, and which that function of x could be a combination of algebraic expression, a sine function, a cosine function, and exponential function. So actually the right-hand side, we place it in our mind that it's possible that it will come out to be an algebraic, a sine function, a cosine function, or exponential function, or any combination of any two. It could be 3 or it could be 4. But if it is 4, that's a complicated problem already, right? If it is 2, a little bit complicated. If it is 1, that's easy money. Okay? Okay, let's try to bring out the solution under the so-called higher order non-homogeneous differential equation. If the given differential equation is of this form here, and take note of it, the right-hand side is not equal to 0, that is a higher order non-homogeneous differential equation. Okay? And the total solution of this is actually, total solution is y without any subscript, and this should be equal to y sub c plus y sub p. Y is the total general solution, okay? And y sub c is the complementary solution. C refers to complementary. Okay? I think under electrical engineering, complementary solution is actually the transient part of the equation. Transient, it only occurs for a certain time. Okay, that's complementary. But y sub p, p here refers to particular solution. Particular solution, it seems complementary is the transient part actually. The part of the equation which only occurs for a certain time. Okay? And the particular solution, even after so many minutes or seconds, that is termed as particular. This is the steady state. Okay? So think of the total solution as a combination of the transient solution and the steady state solution. The transient solution is actually the complementary solution, And the y sub p is actually referred to as the particular solution, and that is actually the steady state. Steady state meaning that part of the variable, that part of the component of the equation that does not vary for how long the time that will elapse, okay? Steady state. But for the transient, for a certain time, there is a value, then after so many seconds, maybe it's gone. Or that is the so-called transient solution. Okay? Total general solution is actually complementary plus particular. Okay, let's try to bring out the applications of higher order non-homogeneous differential equation. As always, it are solve problems under motion problems. We've been through with second order differential equation, and I have brought out so many application problems, the projectile problems, okay, the oscillatory motion of a piece of block of wood that you submerge it, then you try to release it, the cable that was sliding off the roof. Those are actually motion problems. Okay, let's try to bring out the proper way on how to come out with the complementary solution. Actually, the complementary solution is actually the solution under the second order differential equation. Our solution under second order differential equation is actually a complementary solution. And to bring out the complementary solution, we pass by SODA already, right? We let y equal to k e raised to mx. Okay? Then try to solve for dy dx. Solve for the second derivative. If there is a third derivative, take the third derivative, put it on the original differential equation. Then after that, equate the right hand side to 0. That is after the substitution, okay, of this one here. You equate the right hand side to 0. So what will come out will be the so-called characteristic equation. Okay? Characteristic equation, we passed by SODA already. 3 possible cases, right? Real and unequal, real and equal, or the third one is complex number. So whatever will come out, okay, just think of the complementary solution as the solution under the second order differential equation. If what is the method under SODA, just follow that one to find for the complementary solution of a non-homogeneous differential equation. Okay, we forgot the right hand side for the meantime. We equate that to 0 after the substitution, then solve for the characteristic equation. After solving for the characteristic equation, you can bring out the complementary solution of it, right? It will come out. It should be K1 plus K2 plus K3 e raised to, right? It is something like this. That is the complementary solution. It is just only this. A part of the solution. And the harder part is actually the solution on how to find y sub p, the particular solution. Under the particular solution, there is a process on how to take the particular solution. It says here, assume a trial solution using function of x as an image. So if what is given on the right hand side, you base your particular solution on the right hand side. So whatever will be the right hand side, okay, you base your trial solution on that one. So if the right hand side is algebraic, supposed to be our trial solution will be an algebraic, right? If there is a sine function, supposed to be our trial particular solution should be a sine function. There should be a sine function, okay? If there is a cosine, there should be a cosine, okay? In which we do not know yet the constant of integration, okay? That's why it is trial. So I just place it here. Assume a trial solution using f of x as an image. Okay? Oh, that's it, guys. For the meantime, I could not show you this one, not unless I will give you an actual example. Okay? Because it's hard to, what you call this, summarize this one without giving an example problem. As soon as we go to the problem, you could visualize how it was done. Okay? That's the trial solution for the particular solution. Okay, for the last time, an example of a non-homogeneous higher order differential equation is this one. 2d cubed y over dx cubed minus d squared y over dx squared minus 3dy dx plus 4y equal to, for it to be non-homogeneous, it is equal to 2x minus x cubed. As an example, this is algebraic function, okay? And second example, d cubed y over dx cubed plus d squared y over dx squared. This is just an example, okay, of a non-homogeneous higher order differential equation equal to x squared plus sine of 2x. This is just an example. The first one is an algebraic function, and the second one will be a sine function. Okay? Oh, that's the, what you call this, sine. If the given equation is actually a non-homogeneous, the right hand side is not equal to 0, and the left hand side is actually a higher order derivative. Higher order meaning there could be a third differentiation, second differentiation, or first differentiation, or there could be fourth differentiation. That's why higher order, right? Oh, that's it, guys. That's the introduction of advanced mathematics. And the first topic for tonight is the solution of a higher order non-homogeneous differential equation. Non-homogeneous, the right hand side is not equal to 0. Because under homogeneous, this is 0, right? If it is 0, we'll go back to SODE. The only solution is the complementary. But if the right hand side is a function of x, and it could be a combination of algebraic, sine, cosine, or exponential, that is non-homogeneous differential equation, higher order. Okay, that's it, guys. So for those who are taking up advanced mathematics, this is an introduction of advanced mathematics, and the first topic is actually higher order non-homogeneous differential equation, the solution. And this total solution is actually complementary plus the particular. I discussed how to find the complementary. For the particular, this is just the hand. So the next time around, as I give you examples, we could visualize how the particular solution is being derived. Okay, for those who like my long video on advanced mathematics, please click like. If you want to subscribe to it, you will get something from it. Okay, please click subscribe. My channel is at youtube.com/@ProfDavidJ.Reyes. And if you want to share it, okay, you can share it. Okay, please share it. Click share. Good evening, Los Angeles.